Okay, the today's problem is maximum number of balloons. So the given string is given text. We have to use the character of text and form as many instances of the word balloon as possible. You can use each character in text at most once. Okay, return the maximum number of instances can be formed. So length of the text 10 to the power 4 and text only contains the English letters only. So it is here it is written that it is a similar same problem of this 2287 questions. This is just very specific question in the sense like here the target string is hard coded, that is nothing but a balloon. Okay, that is hard coded. So in 2287 problem the target string is not hard coded. See here same question, rearrange the character to make the target string. So you are given a zero index character string target. Here my target is balloon, and you can make some letters from the S. You can take some letters and rearrange them to form new string. So return the maximum number of copies of the target can be formed by taking the letters from the S and rearranging them. So same question, like one text is given, I have to take the characters. Can use the character of the text at most once, and we have to form as many as instance of the our target string. That is the main problem statement. Okay, and and see here the thing is constant here is high, 10 to the power 4. Here constant is low. String is 10 and target string is 10. So this is the thing. I think like it should be 10 to the power 4 or 10 to the power 5 at least. So whatever the thing, let's see our approach. How could we solve the problem? This is our string. So as they have said, like we can check what should I say? As many as possible we can choose. So we can do one thing. We can take our target character. Here it is balloon. I know the spelling is wrong. I intentionally made it wrong. So given a special example. And this is my target string. So let's see how many balloons we can create. Okay. So first, let's see. First my target is B. I have to find B. So let's create one word at a time. So B, this B I can from this B. So this is one balloon. B is created. Then A is there. So A I can take this A. So A is created. Then L is there. I can take this L. L is created. If you consider what I am actually taking, I am taking the first appearance of the character that is and it is not used. See B, first appearance of B, and it is not being used. This is the B. That's why I am taking this character. See for this A, this is the first instance of that character that is not being used. So this way I take L is similarly. This is the first instance of L. I didn't take use. So that's why next character is next target is A. L again. So I will take this L. This L. Okay, let me join the line. Then it will be used. Okay, remove this. So this L I am going to take. This B and L are being used. A and L also being used. This L is also done. Then O. So I can take this O. Then again another O. So I can take this O again and another O. I can take this O. Okay. And then at the end N. So I can take this N. So using this many characters, I have created one instance of balloon. Fine. First instance. Let's see, is there any other possibility or there or not? So first I will check this one. Again B. So this is I can take this B. Okay, let's take different color right now. This is B. I can take this B. Then again A. A. This is the A I can take. Then L. This L I can take. Again L. This L I can take. Okay. And after that O. This O I can take. Again another O. This O I can take. Another O. This O I can take. And at the end in. So this is another instance. Okay. Okay, not this one. This is left. So this is the instance. Okay, and second instance is created. Fine, cool. Can we create another instance of the balloon? So let's see. So I can take this B, and any untouched B present. Yes, this B is untouched. I can take this B. Fine. Then A, any untouched A is there? Yes, this is another untouched A. Then L, this is one L, and okay, L. See here, let me take another L. Another L is missing. I'll give you the same. So another L is there. So I'm taking this L. So L is there. Now see here, O is there. This O is there for single O. Second O is also there. So second O is there. If you notice, N is X also there. So N is also there. But another O is missing. I have used all the characters. I have used all the characters. But another O is missing. This O is missing. That means I cannot fully create this balloon. So it is not acceptable. So my answer is 2. My answer is 2. So similarly, simple kind of approach, like I am iterating each character. So what I actually doing, approach is very simple. It is iterating each character in this balloon B and taking what is the first appearance of the character that is not being used. So how could I do that? So for each character we have to iterate entire, and we have to iterate entire string from start to end, and we have to check like whether this character is present or not. If it is present, then it's good. If it is not present, that means what? I can stop the loop. Okay, I can stop the loop. For another example, let's take this one. Text, and let's say uh, ball, and the string is text. Let's say sorry, it is not text, it is target. So target is, let's say, ball, and text, let's say it is A, B, K, J, L. So this is my target. Okay. So what I will do, simply I will iterate for B. I can check B is there, is fine. Then I will check for A is there, fine. I can check L is there, fine. But whenever I am getting that this L, so this L is not present. Whenever I at the end I don't found any character that is present in the string, I will stop doing that, because it is certain that uh, okay, let me give another example. Like take this L, A, B, L. Okay, this is L is also present, so count will be, there will be count. I will increase to 0. It will increase by 1. Okay, so A, B. Okay. So then I can again iterate from the beginning. That means again I'm searching for B. B is present, so it is fine. Again A I'm searching. A is also present, fine. L I'm searching. L is present. Okay. So again I'm searching for another L, but that another L is not present. Whenever that L is not present, doesn't matter if there is a ball or balls or something is like balla something, whatever it means, I don't know, but still. If something is present, I will stop iterating. We see that whenever one character, I cannot find that one character, I can stop. So that means that next doesn't matter later how many character presents. It will, I cannot create the target string. So there is no point of iterating. The moment I cannot find one unusable character or non-used character and from our text string, I will stop and say like, okay, whatever my current count is there, I will simply return that current count. This is the normal approach you can think, brute force approach you can say. So what actually I am doing then? So to check whether it is being used or not, I need one kind of another extra space to check whether it is being used or not. I can do one thing. We can take another extra space and to mark either it is being false, like kind of flag array. So know that whether it is true or false or not, being used or not, correct? Okay. So function. What is a function name actually? Let me check. Function name is rearrange character something, or maximum number of balloons something. Okay. Maximum target form. Let's say this is the function name. So given is my target for balloon, only target is given. Sorry, text is given, and target is by default balloon. But other problem, target is also given. So I am taking the target as well. Okay, so both are there. So I need one flag array to mark it, like whether that character is being used or not. So I need to create one. What should I say? Uh, Array. One need to have array of length of text. Okay. So for that I need two characters. I need two characters like one. Let's say n. I'm taking n. N I am initializing as n equals to text dot length. Text dot length. Okay. Fine. Then I need another flag. Let's say flag array. I need a flag array. Let's say it's an of integer array of size what, of size n, same size. I need n, and I'm initializing with this, everything is initialized as 0. Okay, so after then I have, how many times I have to iterate, I don't know how many times I have to iterate. I have to iterate the number of instance of that target what could be present. I don't know how many times I iterate. So whenever we don't know how many times we iterate, we simply use while true, because we seriously don't know like how many times we are going to iterate. Okay, it is a infinite loop I am doing. Okay, after that I am iterating, checking for each character. I am iterating for each character for this target, iterating for each character of this target. So that's the reason I am write another while loop, so not while loop, for each loop for each character of my target. Now what I have to do, for each character I have to target. Okay, so here I need what, I need for each character of this target I have to iterate as like whole. I have to iterate each character of the text as well to find a first not used character of for which I am searching. So let me take this example. Come here, this one. Let me put it here. Okay. So for each character, I am again searching for. So for now, I have to search by index. For I equals to 0, I less than n, and then I plus plus, I plus plus. If that flag is being used, then I will continue. I will not take this flag. So if that flag is being used, if flag of I equals to 1, I will simply continue. I will not do anything. I will simply continue. Otherwise, that is not the case. If my character in this same character of, if my character of the text, so text of I is equals to my character what I am searching, if that is the case, then I will do something. So what actually I am doing here, see here. So if I remove this one, for fast character I have to iterate for each character of the target, right? Each character of the target. So fast, obviously I will start with the B, then I will iterate from the text and check whether this is fast, also this is not being used or not. If it is being used, it is used earlier, I will not use them. So if it is not used, then I will check whether this is B or not. If that is not the case, I will check the next character. Here also next character I also check whether it is used or not. If it is used, I will not check. I will take for the next character. If it is not being used, then I will take this case, take this. So that's what I am doing. If it is the case, then I have to do what? I have to like mark this as, like mark this flag of this I. So flag of this I marking as 1. So let me create one flag as well. So let me give one iteration. 0 0 0 0 all at 0. Okay, these are the flag initially. So B, first one is B. I'm searching, this one is not being used, so I'm not I can check with this B or not. So next I can get another B. So this b is not being used. So we'll update this b as 1. I'll update b as 1. So that means it is being used. Fine. So whenever it is I am done, I'm marking this thing as a flag, then I can no need to iterate for any other move. I can stop the iteration and check for the next character a. So that means I'm marking this flag as true and I will break the loop. I will break the loop. So I will break the loop. Fine. Okay. So after that, again next time I will search with the next character. I'll search with the next character. This one. Like this B is done. Then search with the A. So A I will come again and it will search with, okay, A is found, and okay, found, it is same thing. A is found. I'm marking this 0 as A. Oh sorry, 0 as 1, and I will break the loop. Okay. So similarly, then I will search for L. L will come here. L will come iterate. So it will get 1. 1 is being used, I'll not check. B is not being used, not check. K, sorry, A, B is used, so I will not compare with A. K is not used, so I will compare with L. It is not matched. Then I will come at the J case. J is not used, so I will compare with L. So it is not similar. Then this one is not being used as flag is 0. So this L is uh, this character is matching with my current character L. So that's why that I mark this place as a used case. Fine. Next case. So everything is, if it's going good. So this one L, again I'll come iterate from first to last. Then I will mark this 0 to 1. Okay. So mark this 0 to 1. Fine. Then another case I got another A. So this A I will get this, mark this 0 as 1. So fine. So whenever this outer loop ends, that means no many character present. So whenever my outer loop ends at the end, if that the case, then I have to count one case. So I need another variable count, right? So that it makes it as like I have to keep it the track, like how many instance present of the target word, right? So I will make this as count will be one variable I need, that is count variable. So count equals to 0. So initially it is 0. So whenever this outer loop ends, I will simply increase count plus count plus equals to 1. Okay. Okay. So still my inner loop working. Still my topmost outer loop. So we can say this is the outer loop, this is the middle loop, this is the inner loop. Okay. So when the middle loop ends, then I will increase the count. So while as it true, while is true, it will again start doing from the beginning. So another instance will be done, outer loop ends, and again I have to search for B. Again I have to search for B. This B is present. So here the B is present. So fine, I can mark this B as 1. This B as 1. Then next A is there. A is present here. We will come in this place and mark this as A. So mark this as A. So next L is there. L is present here. So this I will mark this L as 1. Fine. Then I will come around this L. Now see what happens here. It will get L. So now it will search for entire array, my text case, and it will iterate. So it will check, and at the end it will also check. It will iterate entire text case, and it will find that this L, my current L is not present. Like not a single instance of L present in my text, that is not being used. So that means I told you at this moment I have to return what is the count present. Like at this moment I have written what is the count present. So that means what? But how could I know that L is not present? So I will iterate the entire loop, and that L is not, should not be present. Okay. So what is the way I can do that? So I need another case, another flag. Let's say found. I need another flag, let's say found. Okay, initialing is 0. Okay, if this is found, then that time whenever the thing is found before break, I also make this flag as true. So found equals to true. So at whenever my second loop ends, whenever the second loop ends, that time I will check. Like if second loop ends here actually. Sorry, not second loop, last loop, inner loop ends here. I will check here if my found equals to 1 0. That is the case. I'll simply return whatever my current count is there. Count. Okay. So I'll simply return the count. Okay. At the end, this function also ends here. So how it is working then? See here. Let's say there are at this moment whenever it checks like when n is not present, we will simply say like okay, it is not found. Found is being not one. Found is 0, that means the character not found. It will return simply count. So what is the current count? I saw only one balla is present, blla. That means it will return only one. Simple approach, but it's a brute force approach. What is the time complexity of this problem? So see, fast approach is it is iterating for how many times at most? At most it is iterating for target into text. For each character it is iterating, right? So for target, let's say size of the target, let's say m, and size of the text is n. So each iteration it can take approx m cross n times every iteration. Now how many times it is changing? It is changing for like it is a while equals to 2. That means actually the number of instance may present in the uh, number of instance of that word present in the target text. Okay, the number of instance of target present in the text, that many times it is iterating. Let's say k times it is present, so it will iterate for k times, because whenever it is not present, it will return. It will directly return is not present. So k times m times n. So this is the time complexity. So if I say like this is iterating for big O of n simply. This is iterating for big O of m, considering m is the length of the target. And this is how many times it will iterate. Big O of k. So k means that k number of times that in like our target is present in the text. K number of times the whole target is present in the text. That is the case. So it is target time complexity is big O of k into m into n. It is too much. And space complexity, we are taking extra array for this flag, right? So it is big O of, and what is the length of that? The length of equals to text. So big O of n. So time complexity is much higher here. So can we optimize this time complexity? Let's see how could we do that. So what is the alternate approach we could use? Instead of checking one character at a time, could we use the frequency? Let's take this example again. Copy, paste. Okay, let's take some more character. It is not relevant. Let's say k m k n, then p, something I have added so that adding some extra character it is not present. So let's first calculate the frequency of target. So frequency of target is frequency of target. Okay, if we do that, or target frequency better. Target frequency. So if we do this thing, what will happen? first see the B is present how many times? One times. A is present how many times? One time. L is present two times. O is present three times. N is present one time. Okay. Let's say text frequency. Text frequency. How many times A present? Let's calculate. 1, 2, 3 times A present. A present 3 times. L present how many times? 1, 2, 3, 4, 5, 6 times. L present six times. Let me fill it up, then I can show it. Making a video in pause, then I will show you how many times present. Okay, here we can see like A present 3 times, L present 6 times, O present 8 times, N present 4 times, B 3 times, K 1 time, P 1 time, N 1 time. Okay, so you can trust me, this is the correct. I am not calculating, so this is the correct approach. So now think, so how could I say like how many times this entire balloon, entire target is present in our text? How many times we could do that? How many times? How we could find it out? How is it possible? So to find it out, like this B, the number of B, how should I say, like to B present, let's say B present here, like balloon present, let's say 3 times. Okay, so hypothetically think, if balloon present in this text 3 times, then what is the case? What should be the condition? This, that means B, that means present here at least 3 times. A also present here at least 3 times, and L is present here at least 6 times. Why 6 times? See, L for create balloon target word, we have to, L must be I have to take 2 occurrences of L. That means if that is the case, then to create balloon from the text 3 times, I need 6 L. And then 2 times of L should be present here. Okay. And for O, 9 times of O should present here. For N, 3 times of present here. So that means we can simply do these things. We can check. That means we can do, like, if text frequency is there, I will take is B already present in there or not. If B itself not present in the text frequency, we can simply say return false, return 0 or something, because that B is not present there. If it is not at all present, then how could we say you can return something is that. So if it is present, let's say B is present, so then what could be the case? If B is present, how many times B present? So B need how many B I need to create my target? Only one B instance needed. How many B is present in the text? 3B present in the state. So I am assuming from this calculation, how many, for looking only the appearance of B, occurrences of B, how many balloon I can form? I am forgetting about other character. How many balloon I can form? I can form 3 balloon, because I can create 3 balloon, and for 3 balloon I need 3 B, and 3 B's are present. So I am assuming like 3 B's are present. Okay, so I will simply say, or make it another B, then we'll understand what I am want to say. So let's say 4 B's are there. So how many balloon, for only seeing, from only looking at the character B, how many balloon or how many target character I can form? I can form four target character, right? So my answer, let's say my answer I will initialize is infinity. So I am considering I can create infinite times of answer. So obviously not now. So my answer will be B, and how many B I need? I can say 4 divided by 1. That many time I can create. Why 4 divided by 1? Because in my text string, B's have 4 occurrences, right? B has 4 occurrences, and to target character, how many B I need? Only one. So how many times I can how many times I can take this B to create my target character. 4 times I take this B to create target character. So this answer becomes infinity to 4. So right now my answer could be 4. Okay, so that means fine. So it is fine. So it is gone. Now I will check for which character. I will character A. So character A, how many times it is present here in the character A here is present for only one time. Okay, so to create my target character I need one instance of A. So here how many times present here? Only 3 times. So see here A is present 3 times. So that means right now how many balloon I can create? 3 divided by 1. Only 1. Sorry, 3 times. So earlier from the B's perspective I can create 4 character. Okay, I can create 4 character, but from the A's perspective I can create how many character? I can create only 3A. So that means I can create only 3. So B is greater than 3. So B can adjust. A cannot increase its character from the text character. So B I can leave creating a 4th balloon. Okay, I'm fine right now. I can only create 3 balloon compared to the just considering B and A, because A is 3. So this answer will be updated by 3. Okay, let's take for a good example. Let's say took another 2L. Okay, so occurrence of L increased to 10. Occurrence of L increased to 10. So in this case, let's see the L. So what is the occurrence of L in the target character? It is 2. What is the occurrence of L here? That is 10. So how many, for using this L, how many character, how many target string I can create? So target string I can create only using the L. So if you just rearrange the question, you can just change the question like this L, how many times this L can contribute to create the target character. Okay, how many times this L can contribute to create target character? How many times? So 10 times it is present, I need 2. 5 times it can contribute. So but the thing is, see here, what is my A can contribute? A is contribute the 3 times. So at the end I have to check what is the, I can create a whole character, whole entire target string. So here, even though L can contribute 5 times, but I need A as well, right? I need A as well. So A can appear only 3 times. So L, I can, from using L, I can only create 3 times. Okay, to create total target character, I need L can be there like 3 times. Okay, so I cannot update the answer. If it is less than, then I will update. If it is greater than, I will not update, because see that less than means other characters can adjust. I can leave other character. But if let's say this A present only 2 times, so I can only, this A can create only 2 times, like balloon, this balloon. So for this balloon I need this A, and balloon I need this A, right? So this A can present 2 times, B present 4 times. So example, B present 3 times. So from this B and this B I can fill this place. But this, for as A equals to 2, I can create this place and this place. But this place I cannot fill. So I can discard this occurrence of B. I can create these 2 occurrence of B. Okay, so that's the reason whenever it is lesser than that, then that time I can take it. Okay, I can update. If it is greater, I will not change, because this lesser amount, like, because that I don't have sufficient amount of other characters to create like more than 3 or more than 5. What is my current answer is. So then see the O, how many times this O is present. If you check number of O, here it is present 3 times, right? It is present 3 times. So how many times O is present here? 8 times. So how many character it can O can contribute? Okay, so that means simply O can be there 8 times divided by 3. That is nothing but 2. I will take the integer only. So 2 times. So this 3 will upgrade by 2 only. And how many times n is present here? N is present here for one time. Okay, so n is present one time. How many times n present here? 4 times, right? So that case 4 divided by 1, it can contribute 4 times, but my current answer is 2, so I'll simply return 2. Okay, this is my approach. If something is not present at all, that time I'll simply return it is not present. If some character is not present, then I will simply return 0. Like it is not present, so I will simply return 0. So let's write the pseudocode then. So let me write it here only. Okay. Let's take our function name is this one. Okay. So this is our function. First, our target is create one two frequency array, so frequency map actually. So I am creating two frequency, one's a target frequency and text frequency. So target frequency, it will be the map of what? One character is the key and integer value will be the integer. So simply take that. Similarly, text frequency will be the map of this one, character and integer, correct? So after that, I need to find the calculate the frequency of each and every case. Okay, so calculate the frequency. What we could do, we can iterate each and every character of the target and each and every character from the text, and we'll simply do plus plus. Okay, so for that we need to like two iterations, two loops. So two loops I need, that is for each loop, for each character in the target I'll iterate. Okay, for target I will iterate. For each target I will do what? Target frequency equal target frequency of that character equals to target frequency of dot get. So we don't know whether it is present or not. If it is present, it will give. Otherwise, by default, there is a some function is there. If it is not present, it will by default return 0. That kind of thing I am using. So plus 1, simple that. So this is the for each loop for the target. Now another for each loop for my text. So for text character in text, same thing I will do. So let me use a bracket here to understand easy. For text, same thing I will do. Text frequency of this character. If it is present, then text frequency dot get of that character. It is present. If it is present, that character, then it is return that number of count. Otherwise, it will return 0. Plus 1, simple. So it is kind of put or default, get or default kind of that in Java. C++, I don't remember any function method name, but it should be there. Okay. Then after that, what I could do? Then I will iterate each and every character. Like I have built this target frequency and this text frequency. Now I will iterate for each target frequency and update the answer. So I need an answer. So answer I need, and I am initializing as infinity. So right now I'll iterate for each character present in my target frequency. For each key or in character, I can say ch, for each character present in my target frequency. If character present in my target frequency, first I will check if it is not present. If that character not found, not present, what should I say? My text frequency, if it is not defined, frequency dot find character, if it is not present, I will simply return at this moment, return directly 0. That means nothing, like if the entire frequency is not present, I can simply return 0, not present at all. Okay, otherwise I will do, otherwise answer will be updated by minimum of current answer or a text frequency of that character divided by target frequency of that character. This is we can do, and at the end the loop will end. And at the end I'll return the answer or count or whatever you can say. Return answer or count, if you anything, any name you can do. What is the time complexity? Time complexity is big O of m. Time complexity of this one is big O of n. M is the length of target character, n is the length of character. So it depends, it is at most big O of m, because at most each target character have unique characters. Okay, so that is big O of n. Otherwise it is less than big O of n if altogether the number of unique characters present in the target. So this is what, and I'm considering accessing hash map, which takes big O of 1 time. Okay, otherwise it will take big O of n time. So I'm considering is taking big O of 1 time accessing the hash map. Even though it's only 26 characters there, right? So if it will take log n time, so then it will become big O of 1 only. The time complexity is here big O of m plus n, whichever is the greater, and space complexity here we are taking any extra space. Yes, we are taking some extra space. So this frequency array, right? So how many times this frequency array can store? It will take 26 times. 26 times, why? Because it is English character letter, right? It is big of 26. So it is at most big of 1. At most big of 1. So as it is the English alphabet letter, it can have 26 characters, and 26 characters, like for a target it can have 26 characters, for text it have 26 characters. In hash map storing key value pairs. So one hash map can have 26 key and 26 corresponding values, so 26 into 2, and here also 26 times of key, and 26 into 2 means 2 while doing like one key also storing one value. So that's why pair 26 into 2. So that means at most it may present 26 into 4 times. At most. At the case it will present 26 into 4 times. Into 4 times. At most it can be present. Okay. So that is, it is big of 1. Even though it's a kind of a constant space. So it's a big of 1. So this is a much better approach than previous. So if you don't want to use hash map, you can use what should I say? You can use one array list. Array. For this you have to convert this array. So as long as it's easy to understand, so I'm using the map. Otherwise we can use the frequency, not frequency array. So 126 length of array, 26 of length of array, and store the corresponding index position. Just map it to the corresponding each character, map to the corresponding index position, and increment that array. I guess you know that approach. Okay, that's all. This is a very easy problem. Two approach you can proceed. So that's the thing. Thank you. As always, if you find any mistake in this video, please let me know so that I rectify. And if you find any useful information on this topic, please also let me know so that I can also learn. Thank you. Bye bye.